Hello guys, welcome to Yebo Tutor live stream help on this beautiful Thursday. How are you all doing? Just type something on the comment section so that we can hear what you are saying. Let's interact. Let's interact on this beautiful day. I'm hoping you are all well. I'm hoping you are doing well. How is grade 12 so far? I think this is the second month of the year 2023. Let's go. Um, you can also type on our WhatsApp group. You can join also the WhatsApp group, which is in the description of this video. You are free to do that. Who do we have? Who do we have? I'm also opening the WhatsApp. So if you text on the WhatsApp, I'll also see that, oh, you are saying something. Let's make this enjoyable. Let's enjoy. Let's interact with each other. If you are a returning subscriber, thank you so much for your consistency. And if it's your first time to subscribe, please don't forget to click on that subscribe button, to like and comment and share with friends so that we can reach out to many people as possible. If you wanna call us, you can call us on Zoom. There is a QR code on your right, left, on your right, so that we can be able to interact with you. So today we'll be doing Euclidean geometry, which is one of the master topics in the maths syllabus. So we know that, as we are waiting for others to join, we know that maths paper 2 consists of statistics, which is 20 marks. Then we know that we have analytical geometry, which is 40 marks. Then we have trigonometry, which is 40 marks. Then the masterpiece, which is Euclidean geometry, which is 50 marks. So just by passing Euclidean geometry, you're already somewhere. So Euclidean geometry is quite a bit hard and a bit challenging, but it's the nicest of them all, because if you understand that Euclidean geometry is all about explaining why are you saying this angle is equal to this angle. So today we're just going to jump in straight to the tutorial of the day and do more questions. If you want to go and check our videos, I did a video on Euclidean geometry last year explaining the different concepts, explaining the different terminologies, different reasons. And also on the WhatsApp group, I'm going to send also a combined documentation which consists of Euclidean geometry only. So please, if you're not on the WhatsApp group, make it a point that you join the WhatsApp group. The description of the link is in this video, so make sure that you will be in the group so that you can be able to receive the material which we give to the students. Let's get down to the business of the day. So in grade 12 we'll be taught only two theories, which have the first one, which is called the proportionality theorem. Then the second one is the similarity theorem. So those two are so crucial because I think in your first term control test, there will be on the grade 12 Euclidean geometry questions, as well as on your controlled assignment, which I believe next week we're gonna do our prepared control investigation. We also do the assignment, and we also prepare for the control test, so that at least we kick the year on high note, on high marks. So just to give you a small overview, on, sorry, just to give you a small overview about this grade 12 Euclidean geometry. So the first thing which is important is to understand that we have what we call the proportionality theorem. Then on the proportionality theorem, we usually look at ratios. I believe you were taught ratios in the past grades, so definitely that's not really hard because we know that what are ratios. So a ratio is a way of comparing numbers by division. So ratios can also be written as fractions. So e.g., we are saying that if we compare line AB and line BC, this is a ratio, but this same ratio can be written as a fraction, which is AB over BC. So this is a ratio. So I know you are well exposed to ratios. You have been doing them since grade 1, grade 2, grade 3. So we are saying that in the proportionality theorem, we must be able to understand what are ratios and how do we apply our ratios. So I just did a small example that if we say line AB is to line BC, it's the same as AB over BC, and the ratios are illustrated by the semicolon so that at least you can be able to have things in the correct format. So now we must always be able to understand that the ratios usually, it doesn't really necessarily represent the length, just like an example which I did, uh, but it can represent other things. So in order for us to change the ratios to length, we can multiply by a constant. So for instance, we are given AB over BC is equal to 2 over 3. So what does this mean? So we say that this is the same as, let me just write it something. So we say that when it's AB is to BC, it is the same as AB over BC. So when it's 2 over 3, this is the same as AB is equal to 2 and BC is equal to 3. So we can see that, let's remove this part. Okay, thank you. So on this part of this 2, we can actually see that this does not mean, this doesn't really mean that AB is equal to 2 units and BC is equal to 3 units. But it means, AB is equal to 2K units, then BC is equal to 3K units. This is you understanding the ratios. This is you understanding the ratios. Check it out. Example. If P divides a line segment AB into the ratio 5:4, determine the following ratios. So this is just like an example. So for instance, we say our number A will be determined AP over AB. Then our B, we say maybe AB over AP. Then on C, we say PB over AB. So now, in order for us to understand what's going on here, I usually love to do illustration. So I used to say, or like last week when we were doing our number patterns and sequences, I say it's so crucial that as a student, you conceptualize the question, that you visualize them, you conceptualize them so that you can be able to understand what's going on. So we're saying that if P divides a line segment AB, so what is this sentence meaning? It's telling us we have a line segment AB, and the line AB is being divided by P, so that now we have the ratio of 5:4. So maybe let's remove our P so that at least the P can be a little bit somewhere here. Then we say we have our 5:4. So this is what is so important to understand. What do we have in the question? So now that we know that this is what we have in the question, then everything which we want is going to be so easy for us, because this is what is important. So if you just write that 5 now, your answer is not going to be correct. That's why I was introducing that we have 5K and 4K, because we don't really know the value of AP and the value of PB, because we were only told that the line the line segment AP is divided by point P. So now if we just say 5,4, that is making our answer definitely wrong. So now check it out. This K is so important because it's going to make you be able to determine the few things which you're going to do on the proportionality theorem. So now, AP over AB is equal to AP, it's 5K, AB, it's 9K. So now we can divide those K, then now we have 5 over 9. It's making a little bit of sense, but as we are going to do more questions, it's going to make more sense. On B, we said AB over AP. So this will be 9K over 5K. We divide, we now have 9 over 5. Then C, we said PB over AB. That's easy because we know that PB is 4K over 9K. Then now we have our 4 over 9. So why am I showing you this? I want you to get relevant to what is important and to what is so crucial. Now, before now we go further, in our grade 12 work, we will be exposed, if you have not yet studied Euclidean geometry, about the different triangles. So now we have three triangles, three types of triangles. We have the isosceles, the right angled, we have the scalene, we have the equilateral. So sorry, so they are not three there. We have different types of triangles. Let me just use that term. So the isosceles, where they are two sides which are equal. We have a scalene, where all sides of a triangle are not equal. We have a right angle triangle, a triangle with a 90 degrees, which we're using when we're doing our um, trigonometry. Then now we have this other one, which is the equilateral, which have all sides which are equal. So now, if now we say we have two cases, now we can say our case one will be, if we are saying the triangles, they have the same base and same height. Okay, this is Euclidean geometry, guys. So same base and same height. So for instance, say let's say we have our line here, then we just maybe draw something just for the sake of drawing, let's just say this, then you can say we have another one here. Let's say this is D, let's say this is B, and now we just join these two on top here. Just giving you the basics, guys, of the grade 12 one. Then we construct our height here. And we say this is our height, this is BC, this is BD. Then we can maybe say this is height 2. this can be height 1, then the other one can be height 2. Then now we can actually see that the height 1 is equal to height number 2. Why? Because we can see, or let's just also highlight these two lines are parallel. So we can see that AD is parallel to, so this is my A, B, C, D, S. So we can see that AD is parallel to BC. So we know that the parallel lines, they are giving us these two heights equal. So these two perpendicular heights which I've constructed, they are coming from the same base. So now since the base is the same, then there could be, so there is this which is taught, I think, in theorem number 3 or 4 of grade 11 work. We say angles are obtained from the same segment. So those segments which you're talking about, they are so crucial and so important. So those are the few things which I wanted to highlight. But let me just jump straight to the business of today, which is the theorem 1, which is called the proportionality theorem. So this one, I won't prove it, but the proof is examinable. So always know that the proof is examinable. So let's say A, uh, B, C, D, and E. Okay, so we have our parallel lines here. So we can definitely conclude by this uh, triangles which we have according to the proportionality theorem, which states that a line drawn parallel to the one side of a triangle divides the other two sides proportionally. What does this statement means? Because this theorem is so important. So this theorem says that we have a triangle here which is A, B, C, and we draw a line which is parallel to one side of a triangle, and it will divide to form two sides which are proportional to each other. So if this is our D and this is our E, then according to the proportionality theorem, we can actually conclude that AD over DB is equal to AE over EC. Why? This is because of the prop theorem. So this is the reason. You don't have to say proportionality theorem as a whole, but you can just say this is the prop theorem. So this is so important, guys, for you to just understand these small basics. Okay. Now, going forward, we can actually also say that AB, sorry, over AD is equal to AC over AE. Just look at the beauty of this proportionality theorem. Just because of understanding the definition which we are given, that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So when we were doing the ratios, it was building to where we are now. So it's leading for us to understand the proportionality theorem, that when we're doing the ratios, just saying AB is to BC, we can write that ratio as a fraction. So now when we are coming to the proportionality theorem now, we are now dealing with what is so crucial. So proportionally now we are saying that when that line drawn from one side parallel to the one side of a triangle, it's gonna lead us to have two parallels, two proportional sides, which are these sides here. So these two, they are proportional to each other. So you can actually find out that AB is equal to AC and AD is equal to AE because of that line which has been drawn. So if you just understand that only part on this part of proportionality theorem, then you are done. So when this is important, let me just say NB. So when you are writing the reason, why are you saying AD over DB is equal to AE over EC? Why are you saying that? You write in your brackets and say that this is because of prop theorem. Why are you saying this? Because we have parallel lines. In this instance, the parallel lines is DE is parallel to BC. So why am I showing you this reason? This is so important because if you write just that AD over DB is equal to AE over EC, your answer is not going to have weight. Bear in mind that when we are solving problems in Euclidean geometry, the beauty comes when you are able to explain your answer. So for instance, when we are having parallel lines, we know that where there are parallel lines, we can have a Z and the Z have alternating angles. If you're just saying alternating angles without showing which lines are parallel, which means your answer is not fully having all marks to be rewarded to you, you'll be partially correct. Because if you just say that angle A is got to angle B, alternating angles, from which lines are parallel? So it's so crucial that we are saying that this over this is equal to this over this. Then we say prop theorem. Now we should, it's a must that we state the parallel lines so that we can have all the marks. The goal is for us to get all the marks. If we're having straight lines, we know that this can form our opposite vertical angles which are equal to each other. So if we just say this and this are equal to each other and you don't state that they are vertical angles, then your answer is not going to be correct. So always state your reason, and also if you are dealing with parallel lines, state the parallel lines. For instance, if a form F is formed, then we know that we have our corresponding angles. I am saying mine, see yours as yours. So this is like an F shape like this, then this line is parallel to this, so this angle and this angle, they are equal to each other. Why? They are corresponding angles. That's a good answer, but you should state which lines are parallel to each other. The moment you are able to state those parallel lines, you're gonna get your full marks. Please, I have repeated that part because it's so crucial. That's where we lose our marks. Your answer can be correct, but if you don't state the reason, your answer is partially correct. So that's not what we want. Okay, I am hoping we are all together. I haven't seen anyone typing anything on our WhatsApp group as well as our comment section. Feel free. I saw Kanye also commented. Please feel free to comment so that we can proceed together and understand in the process. Now, let me just move fast and let's talk about the similarity theorem. So the similarity theorem now, it's not that bad, but it's for us just to understand. Oh, before I go to the similarity theorem, let's speak about the converse. The converse of proportionality theorem. Okay. Proportionality theorem. What is it converse saying? So the converse say if a line divides two sides of a triangle proportionally, then the line is parallel to the third side of the triangle. I want you to listen to this English. If a line divides two sides of a triangle proportionally, then the line is parallel to the third side of the triangle. Let's put this into illustration. So this is our triangle A, B, C. So we say that if a line divides two sides of a triangle proportionally, we can see that we have tried, mine is not really accurate, but you can see that we have divided two sides of a triangle proportionally. Then the line is parallel to the third side of the triangle. So the moment that line which is drawn and it is able to divide the two sides of a triangle proportionally, then we can see that this line is parallel to this line. That's all. That's all. This is our converse theorem. We use the converse theorem every time when we are proving that this surely is prop theorem. So in order for you to prove that this is proportional theorem, you should prove using the converse theorem, which says that if a line divides two sides of a triangle proportionally, then the line is parallel to the third side of the triangle. So those small things, they are so important. Okay. So for instance, if we say this one, then we have our DE. So now the reason will be different. Let me just put an NB once more. So now in this converse, we can now say AD over DB is equal to AE over CE. Why? Converse prop theorem. So this is how you write your reason. I'm showing you this because it's important. On this side, you say prop theorem, then you state the parallel line. Then on the converse of proportionality theorem, you just say converse of prop theorem. Then after that, you have your good high marks. Sorry. Is there any question? Is there anyone with any question? Is there anyone with any question so that we can move forward? Okay. Seems like we are still on the same boat. Now let's focus on the similarity theorem, okay? Here is our similarity theorem. So on the similarity theorem, definition, this is just a small overview. I won't give you all the details, but I just want to highlight the things which are important. So for instance, if we have these two triangles, just say A, B, C, D, E, and F. Okay, these are my two triangles. But let me just use X, Y, and Z. Okay, so that at least it can be quite good. So we use this when we are proving as well that these two triangles or these two angles are equal to each other. So we can see that corresponding angles are equal, that in, which means this angle A is equal to this angle X, then this angle B is equal to this angle Y, then this angle C is equal to angle C. Let me just write it. Angle A is equal to angle X, as well as angle B equal to angle Y, as well as angle C equal to angle Z. So that's something which we are considering. So the corresponding angles, they are equal to each other. So if we say the corresponding angles, also the corresponding side should be something like this, which is AC over XZ, which is also BC over YZ. So this is what we are talking about. So this theorem states that, or the definition of this theorem, it states that if two triangles are equiangular, let me just write that down. If two triangles are equiangular, then their corresponding sides are in proportion, and therefore they are similar. Therefore they are similar. This is good. This is good because everything on this definition, we've already showed it here. But now the proof is so crucial, guys. The proof is so important because if you don't know how to prove these two theorems, you will lose 7 marks. So always practice how to prove, So after this small, so let me just write it down here. And let's also have another one here. Then we say this is our triangle ABC. Okay. Move that part. Then now we can say maybe we have Q, R, and S. Then now we say that initially, if two triangles are equiangular, which means this angle is equal to this, the corresponding angles are equal to each other, these are also equal to each other, then now we are saying that their sides, their corresponding sides, they are in proportion, then therefore they are similar. So we have already said that if we are saying that the equiangular angles are equal to each other, then the corresponding sides in this instance, there will be, choose a different pen, so it's going to be AB over QS, then AC over QR. So those are the corresponding sides, they are in proportion. Then if those two things are in line, then therefore we can state that therefore triangle ABC is similar to triangle QSR. So those things are so important, guys. So the reason in this problem, or when you're stating your answer, you can just say that angle, because you are speaking of equiangular angles. So this is how you just show this and prove. So I've just showed you these two proofs. I just give you a quick overview, a quick summary, so that you can see that these two, they are so important. And also, what is important about these two theorems is that when you're doing your assignment, which I believe that you'll be given anytime from this month, it's so important that you understand this similarity theorem as well as the proportionality theorem. We are not eliminating the stuff which I've done in grade 11. They are so important, they are so crucial. But for your first term, you must really focus on make sure that you understand these two theorems which you have highlighted here. Let's try to just do one question. Then when we have our tutorial next week, Monday, then we can do more questions. Great. So this is coming from 2019 June, from the Department of Education. Let's look for one question to do there, which include the similarity theorem. You can ask your question on the group. You can ask even on the comment section. So let's try to do these two questions. I love them, but this one is for proof. In the diagram below, triangle KLM is given with R and S on KL and KM respectively, such that RS is parallel to LM. Prove the theorem which states that KR over RL is equal to KS over SM. This is so sweet. For all 5 marks, what you just have to do is to understand how to prove this theorem. So in other words, when you go to your exam, just always know that you must know how to prove. So the proof, definitely, let me just prove it with you guys so that at least it can be nice. Let's prove it together. So what are we given to prove? So we are given this triangle. Let's do it together. Let's see if we can prove it. Okay, so we are given this triangle, which is something like this. Mine is not that nice, but it's saving the purpose. So we have KL, M, then we have RS. So these two are parallel. And what are we required to prove? We are required to prove that KR over RL is equal to KS over SM. How can we prove this? Let's prove this. 5 marks, 5 minutes. Let's prove this together, guys, so that it can be so nice. Now, how do we prove this? In order for us to prove this, when I started this session, I started by speaking about the same height, same base. Now, let's apply that same information. Let's apply the things about the ratios and put it into one thing. So, let's start by constructing two different heights, okay, so that everything can be good. So, let's do this. Then we also do this. then we construct a height here, then we also construct another height here. These are perpendicular height, it forms 90 degrees. This one also form 90 degrees, so we can say this one is our height, then we can say this is maybe our height number 2, so this is our height number 1. So how can we prove? So now already we have constructed. So what you do is what you also write. And I love the fact that on your paper 2 booklet, you are given this diagram. So you can just construct on that diagram which have been given on your booklet. So now we just write construction. Always in all the theorems, I think 3/4 of the theorems, you must start by construction. So what did we do here? We draw height, the heights, which is height 1 and height 2. This is what we do. And on or we drew heights h1 and h2, which we can see that we drew with this. H1 is on kr, h1 is on kr here, then h2, this one is on the line kr, then h2 is on ks, so that at least people don't get confused on that part. Then we also joined SL and MR. Okay, so we are basically explaining what you have done. Then you get your 1 mark just for this construction. So we started by drawing heights, height 1 on the line KR. Then we also drew height 2 on the line KS. So when you're doing Euclidean geometry, stop worrying about other people. If you want to turn the paper upside down, turn it down. If you also want to turn yourself upside down, like so that you can see what's really going on, also do the same thing so that you can be able to see it. Others use highlighters, others do this. So it just depends on which one is best for you. So we started by construction, then we are done on that part. Now let's move. So the area of triangle, let's say K RS, triangle K RS divided by the area of triangle RLS. Yes, RLS is equal to, how do we find the area of a triangle? Half base times height. So it's going to be 1/2 KR multiplied by our height 1. Then also on the base is going to be 1/2. Then our base is RL times H1. Someone will say you can't see R1. Let me show you now. Let's use this one. So this is R, L, and S. So this triangle is something like this. Yeah? So we have our R, our L, and S. Now we are saying it has this height number 1 because you can see that if we do this, this is gonna join to that KR. So we can see that this is now our perpendicular height of this triangle RLS. Just think about it and redraw it. So the beauty of Euclidean geometry is that you can reconstruct or redraw in a way that you can be able to see. You can actually separate triangles as well. So we can see that this is our RLS here. Here is our triangle. Then this is the perpendicular height. So we can see that the height is the same. And for the triangle KRS, we can see that the base is KR and the height is still R1. So it's still H1. So now we can see that this will be height 1 and height 1 will cancel, half and half will cancel. Then we have KR over RL. Now let's look from the other side now. So if we say area of triangle KRS, okay, over, let's see, What are we required to prove? KS. So let's say KSR, so that at least everything can be good. KSR over area of triangle. Definitely now we are looking at the other one, SML. So SML. So again, it's gonna be half. Base is KS times height 2 divided by half. What is our base in this instance? SM times our height 2. Then height 2 and height 2 will cancel, half and half will cancel. Then we end up having KS over SM. Now we have already seen that this is the other the other ratio. This one is the other ratio. But how can we now conclude that these two, they are equal to each other? That's when now we say but. Okay, what's happening here? But we can see that the area of triangle LRS is equal to the area of triangle MSR. Why? Why? That is the important reason which will enable you to get another mark. Check this out. We are saying that but area of LRS LRS. So this is the triangle which you're talking. The area of this triangle is equal to the area of MSR. Let's use a different marker so that you can see. M, S, and R. Why? Do you see something here? They have the same base here, which is, this is nice. Do you guys see that? These two triangles, they have the same base. So that's why we're saying that but the area of triangle LRS is equal to the area of triangle MSR. Why? Because they have the same base, same height. Do you see that now? We are going back to this first point which we highlighted, which was talking about the same base and the same height of a triangle. So therefore we can see that, oh, this is what we were talking about right now. Then after that, now we can proceed, since now we have concluded this, that these two triangles have the same base and the same height. Their area, they are the same. So now we can then they say, therefore area of triangle KRS over area of triangle LRS is equal to area of triangle KRS, or divided by area of triangle. Where is this? Oh, last time we used RLS. So this part we can just use RLS. Then this one we can use KSR. This one we can use SMR. Now we can then say, then therefore KR is over RL is equal to KS over SM. So now we have proved what we have been asked to prove. Just to highlight the most important part, the first thing which we did was to do the construction. After we constructed, what did we do next? We joined SL as well as MR. Then after that, we calculated the area of the different triangles. We had approximately 4 triangles here. So we said the area of triangle KRS, which is KRS is half base times height. We know that from grade 8. So we just used the same principles. Then we ended up having the ratio KR over RL. Then we proceeded, we say area of triangle KSR, which is the other side now. So we started by looking at this side here only, here. This other side, now we are now looking on the other side. So the area of triangle KSR. Then we also looked at the area of triangle SM. They have the same height. Then after that, we also saw that these two triangles here, triangle LRS and triangle SMR, they have the same base, and we can see they are parallel lines, which means they also have the same height. Because you still remember when I say that we have two parallel lines like this, and now we have our two triangles here, then we say that they will have the same height because they are within two parallel lines. Now you get your 5 marks just for being able to do that. Any question, guys? Let's make maths fashionable. Oh, thank you so much, Lisa. Thanks for clearing up my confusion surrounding corresponding angles. Yes, yes, please. That's what we are here to do. Please don't stop commenting so that we can interact and just enjoy each other in the process. Now, let's proceed to the next question, so that we can see where we are going together. Now, let's look at question number. Let's look at question number. You get it? Yeah, it is 10.2. So it looks ugly. But what do? We attack. In the diagram below, triangle ABC is drawn with D on BC and F and E on AC, such that AB is parallel to FD, BF is parallel to DE, AB is perpendicular to BC, and BF is perpendicular to CA. Furthermore, CA is equal to 13 units and CB is equal to 12 units. This is great. This is amazing. So this question is basically dealing with what you have done already now. It's showing us there will be prop theorem here because of those many parallel lines. There will be similarity theorem here. So let's show each other how do we answer these questions. Now let's read the question the second time. So when you're answering question, you don't just read once then like okay, cool, now I understand. You read at least twice or thrice. So now in the diagram below, triangle ABC. So from where you are watching us live right now, go to the triangle. Where is triangle ABC? Here is triangle ABC, ABC, which is the biggest triangle which we have there. Then it is drawn with D on BC. Where is D? D is situated on the line BC, because now we are reading, then we are going to the triangle. Then also we have F and E on AC. So we can see that from that line which is AC there, we have F and also E. So those 2 points are situated on line AC. Then now we are given two parallel lines. We are given that AB is parallel to FD. AB is parallel to FD. So you can see that AB is parallel to FD. Then we are also given that BF is parallel to DE. Turn around if you can't see it so that you can be able to see it. So we can see that BF is parallel to DE. We can also see that AB is parallel to DF. Definitely there is prop theorem here. Then you're also given that AB is perpendicular to BC. The moment you see perpendicular, that's 90 degrees. Then also BF is perpendicular to CA. That forms another 90 degrees. Now, let's look at the question. What do they want from us? Write down the length of AB. Where is AB? Here is AB. So what is the length of AB, guys? This is quite nice. What is the length of AB? Can someone type something on the comment section so that we see that we are together? What is the length of AB? What is the length of the line AB? What is the length of the line AB? Okay, that one was easy. That was for everyone to get something. So the line AB will be equal to what? what will be the length of AB. Let's talk it out together, guys. Let's make it fashionable. Let's make it nice. What is the length of AB? Okay, since you didn't want to say something, so do we see that that triangle ABC is a right angle triangle? So we can use our Pythagoras theorem, which says that r squared is equal to x squared plus y squared. In this instance, 13 squared is equal to x squared plus 12 squared. Then 13 squared minus 12 squared got x squared, sorry. Then we square both sides. Then our x will be equal to, that should be 5, because it's gonna be 269 minus 144. We use our calculator, guys. Where is mine? So we use, and we always use our Casio calculators. Let's use it. So square root of 13 squared minus 12 squared. Then we get our 5. Where is your Casio calculator? In order for you to pass, use your Casio calculator. So we have our 5. So the value of AB is equal to 5 units, because yes. Now, just what you have realized in this question is that when you are doing Euclidean geometry, you also apply your skills which you have acquired. Oh, thank you so much, Kanye. AB is equal to 5. Yes, she was also able to see that it's equal to 5. Yes, thank you so much. So what we have also learned is that it's so crucial to realize that we have some parallel lines in the process, AB and also DF. And also we were able to see that due to that AB parallel to BC and 90 degrees being formed, that we have our right angle triangle. So Kanye's mind was able to realize that, oh, okay, since there's a perpendicular line and there's a 90 degrees which is formed, then therefore this means that there is a Pythagoras theorem which we can use from trigonometry. Now let's go. 10.2.2. Thank you so much for interacting with us. Prove stating reason that a triangle CBA is similar to triangle CFB. This is so easy. It's only 3 marks. How can we prove that triangle CBA is similar to triangle CFB? How can we do that? This is easy. What? Firstly, number 1, angle C is equal to angle C. It's both common in both triangles. So, in order for us to prove this, sorry, I forgot one important statement here. We start by writing that in triangle CBA and triangle CFB, because we are still proving. We can't just say angle C is got angle C common. No, 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 no. Start by stating that in triangle CBA and triangle CFB, so that we know what are you doing, what are you talking about. So we can see that angle C is equal to angle C. They are both common. Great. Now we can see also number 2 that angle B is equal to angle F. They are both equal to 90 degrees. This is just easy. CBA is equal to CFB. We can see those 90 degrees. Here is the 90. Here is another 90 degrees. Then now we are left by just saying the last one, C angle AB is equal to C angle BF. Definitely we know that sum angles of a triangle. So this last one is usually just written like this. You just look at which one you were not able to find, okay? Because we know that the sum of angles of a triangle, they add up to 180 degrees. So if we are able to find 2 angles or 2 sides which are equal to each other, or proportional equal to each other, sorry, then definitely the last reason can be the sum of some angles of a triangle. So then therefore triangle CBA is similar to triangle CFB. Why? Angle, angle, angle. There is a mark for showing that it's angle, 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 angle. So after that, you get your 3 marks just for being able to see that it's angle, angle, angle. Now on B, now prove stating reason that CF is equal to CB squared over CA. How can we do that? So since we have already proved the similarity theorem, or we were able to prove that CBA, triangle CBA is equal to triangle CFB. So the fact that we are able to prove that part, now this makes everything easy for us, because now we are able to see that CB over CF, CB here over CF is equal to CA over, so it's CA like this over CB. What's the reason? Similar triangles. Now everything is now building up, okay? It's because of similar triangles. Then we can see that you multiply, we have CB squared is equal to CA times CF. Okay, then you can see that CF is equal to CB squared over CA. Wow, then you get all your 3 marks. 1, 2, 3. Then you are out. Get your 3 marks, we pass, we move. Okay, now on 10.2.3, hence determine the length of CF. Wow, this is easy. CF, we have already found it from the above, that CF is equal to CB squared over CA. That's why they started by saying hence. The moment they say hence, don't even worry about looking in different sides, different angles, which means use what you have calculated above. The moment you see the word hence, you use what you have calculated above. Okay, now how can we do that? We know that we have our CB to be 12 square it divided by our CA, which is 13. They said to the nearest 2 decimal places. Again, don't crack your head. Use your Casio calculator so that you can get the correct values. Can I get the value of CF? Can someone just give me or type on the comment section what is the value of CF? What is the value of CF? I'm also type. What's the value of CF? I'm waiting for someone to say something. What's the value of CF? 11,08. Thank you so much for your response. I trust your calculator, and also my calculator is also saying the same thing. But now, can you underline that part? Correct to the nearest unit. So we are not correcting to the nearest 2 decimal places. So our correct answer there is going to be 11, because of the instruction which you're given, that correct to the nearest unit. Thank you so much for the response, Kanye. It shows that we are together. So always, guys, just to just explain more on that part, just when you're answering question, also don't forget to listen to what is the next sentence or what is the instruction for that specific question. So when you're reading the question papers, definitely there are like rules and stuff. So we know that they always say that round off to the nearest 2 decimal places. But in these special instances, sometimes they say to the nearest 1 decimal place, sometimes they say to the nearest 3 decimal place, sometimes they say to the nearest unit. So we must listen to that part. Yes, thank you so much. Let's proceed to do 10.2.4. Give the length of AF. 10.2.4. Give the length of AF. How can we see AF? AF is so easy. AF is so easy. How can we find the length of AF? Where is this triangle? Let's look at it again. We want AF now. We want AF now. We know that AB is 5. Now we want AF. Now we want AF. what will be the length of AF? Only 1 mark. Only 1 mark. Only 1 mark. What will be the length of AF? What will be the length of AF? Someone typed on WhatsApp and said the length of AF will be equal to 2 units. Yes, that's correct. So it's going to be 13 minus 11. Then we get our 2 units. That one is correct. Now, determine the length of FE. 5 marks. That's a lot. Determine the length of FE. Where is FE? Where are you, FE? Oh, here we can see it. Here is FE. Let's solve it. It's 5 marks. Leave your answer in the form A over B. That is possible. That's doable. That's doable. Let's do it together, guys. So we can see that firstly that CB over BD is equal to CA over AF. Okay, why? Because of the prop theorem. But in this instance, we can see that we have two parallel lines, two sets of parallel lines. We have the one for AB parallel to DF, and we also have BF parallel to DE. So which parallel lines are you talking about? So in this one, I'm talking about DF being parallel to BA, or you can just say AB parallel to the other side. Then after that, let's look for the value of BD. We know that CB is 12 over BD. Our CA, where is our CA? Where are you, CA? Where are you, CA? CA is 12. Is it? Sorry, it's 13. What is our AF? Our AF, we just calculated it now, it's 2. So BD will be 12 times 2 divided by 13. Then we get our BD to be 24 over 13. Okay. Always I advise don't round off before the final answer. Okay. Then also we can also see that CF over FE is equal to CB over BD. Again, why are you saying that, Fuyani? It's because of prop theorem. Now let's take the lines. TF parallel to BA again. Then after that, what is our CF? Our CF, we calculated it was 11. Our FE is what we want now. Then it's going to be 12 over 24 over 13, because BD here is here. So please, next time, don't even try to round off, because if you round off, you're going to get wrong answers. Okay. Then after that, we do what you're supposed to do. Then you can see, therefore, our FE is equal to 22 over 13 units. Then you get your 5 full marks. Just to highlight something fast before we close our session. So what is important in this question is that you understand the prop theorem, and you understand and you use it. So in these two questions which you did, we started by proving the prop theorem. We also used the importance of the similarity theorem, because we use the similarity theorem here to be able to prove that triangle CBA is equal to triangle CFB. Then from that part, now we're already using what you have already proved in the process. Thank you so much for tuning in on the Yebo Tutor live stream help on this beautiful Thursday. Please share with your friends. Please share with family. We stream live, and when we stream live, we notify in our WhatsApp group. I'll give you the materials tomorrow in the WhatsApp group. So if you're not in the WhatsApp group, do your favor and join in the WhatsApp group so that you can be able to receive the material. Till we meet again, have a good, blessed evening.